Let's delve into the world of sequences. Sequences are just lists of numbers, and it's important to understand different types of sequences before we talk about our first one. Sequences can either be infinite, which means the list continues on and on and on forever, or they can be finite, which means they end after a certain number of terms. And there's lots of different types of sequences. The most common is the arithmetic sequence, which means there's a pattern that involves addition or subtraction. There's a geometric sequence, and the pattern involves multiplication or division. Sometimes there's a different type of pattern, an other pattern, or sometimes there's absolutely no pattern at all. The arithmetic and geometric are the most common that we're going to start with, and let's start with dealing with the arithmetic. An example of an arithmetic sequence, very easy, would be like 3, 5, 7, 9. 3 would be the first term, 5 is the second term, third term, fourth term, and so on. And those dots just mean that this particular sequence goes on forever following this same pattern. If you hear the term or element or member, they all mean the same thing. It just means your first number, second number, third number, fourth number, so on. We're going to use the word term. There is two very important formulas. The one that we're going to use most commonly is this one. So the nth term is going to be equal to the first term plus the number of terms you have in your formula or in your sequence, minus 1, times d, which is the common difference. Or you could also do this one, it's going to be the same thing. You'll also see this formula here as a function of mx plus b, and you'll notice this is talking about the equation of a line. These two things are talking about the same sequence. They just kind of look at it from a slightly different perspective. Let's do kind of an easy kind of example here. Let's say I have a sequence and there are 5 terms to it. And let's say my sequence is something easy like 6, 8, 10, 12, and 14. So my first term is 6, my second term is 8, third term, fourth term, and fifth term. Okay, what does this mean? The common difference, basically you can see the pattern here. Each term is being increased by 2. Or the difference between the term and the term previous is 2. That's where we get the term common difference. Okay, that's nice. A is my first term, so A in this one would be 6. D is my common difference, in this case D would be 2. And how many terms are there? Well, in this case there are 5 total terms, so total terms would be 5. Great. What does this mean and how does this describe it? This says that the nth term, let's say I'm going to pick my 5th term, which in this case is 14. My 5th term is going to be equal to my first term, which in this case is 6, plus the common difference, which is 2. This is talking about how I'm jumping by 2 each time. So this is jumps of 2. And how many jumps of 2 do I have to get to my 5th term? Well, I have to take from my first term 1 jump, 2 jumps, 3 jumps, 4 jumps. Well, I have 4 jumps to get to my 5th term. So that's where that n minus 1 comes in, because I have 1 less jump because I'm starting at my first term. So starting at the first term, I have 1 less jump, and my jumps are 2 steps in length. That's how that one works. Let's talk about how this is almost very similar with this one. I'm still going to use my 1, 2, 3, 4, 5 terms. 6, 8, 10, 12, 14. I still have my first, second, third, fourth, and 5th term. Okay. What happens here? Well, in this case, m is going to be my common difference. Okay, notice D and M are basically the same thing. Now B, instead of saying I'm going to start at my first term, B says I'm going to start at my 0 term. What in the world would be a 0 term? Well, a 0 term would be if I went back from my first term. If I'm going forward by 2, my 0 term means I'm going back by 2. So that would leave me at 4. My 0 term following this pattern would be 4. So according to this, if I want to describe my 5th term, for example, f of 5, my 5th term, my input of 5 would be 2, how many jumps? Well, I have 5 jumps. That gets me my 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. Let's do those, right? That gets me my 5 jumps. But in order to get 5 jumps, I have to start back at the 0 term. So 4 plus 5 jumps of 2 gets me to 14. So these are the same, they're describing the same pattern and you can get to the same place. It's kind of like two sides of the same coin, just a slightly different perspective.